Today we are going to talk about the galactose metabolism and its disorders. So first of all, let us discuss about how galactose is metabolized. So first of all, we take a carbohydrate molecule that is galactose. Galactose, with the help of the enzyme aldose reductase, it is converted into galactitol. So galactose, with the help of enzyme aldose reductase, it gets converted into galactitol. So it is the one of the reaction that helps to convert galactose to galactitol. So another reaction what happens is that with the help of the enzyme galactokinase, it is converted into galactose 1 phosphate. So galactose is converted to galactose 1 phosphate with the help of the enzyme galactokinase. And with the help of the enzyme uridyl transferase, galactose 1 phosphate uridyl transferase, the galactose 1 phosphate is converted into glucose 1 phosphate. And so the glucose 1 phosphate may enter into the glycolysis or glycogenesis. So this is the main thing that happens to a molecule of the galactose. The galactose ultimately can be converted into galactitol, or the galactose may ultimately metabolized into the glycolysis or glycogenesis. It can ultimately goes into this reaction to generate the energy. Now let us discuss the various disorders of the galactose metabolism. There are mainly two disorders of the galactose metabolism, that are galactokinase deficiency and another is classic galactosemia. So first of all, let us discuss about the galactokinase deficiency. In this galactokinase deficiency, there is hereditary deficiency of the galactokinase. So what happens when there is hereditary deficiency of the galactokinase? So the galactose will not be converted into galactose 1 phosphate. Rather than that, due to the enzymatic activities of the aldose reductase, there will be the high conversion of the galactose to galactitol. So there will be the accumulation of the galactitol. The galactokinase deficiency is mild and it is autosomal recessive disorder. So what are the various clinical features of the galactokinase deficiency? They are galactosemia, galactosuria, infantile cataracts. Why the infantile cataracts occur? When there is deficiency of aldose reductase, when there is deficiency of galactokinase deficiency. I will discuss that in the classic galactosemia, and there will be the failure to track objects, or there will be the failure to develop the social smile. So these are the various clinical features of the galactokinase deficiency. So another disorder is the classic galactosemia. In the classic galactosemia, what happens? There is the absence of the enzyme galactose 1 phosphate uridyl transferase. So this enzyme, uridyl transferase enzyme, is missing in the classic galactosemia. It is the autosomal recessive disorder. So what happens when there is deficiency of uridyl transferase? There will be the accumulation of the galactitol and the toxic substance. What happened? The galactose and the galactose 1 phosphate will not be converted into the glucose 1 phosphate, and eventually there will be the more conversion of the glucose to galactitol by the enzyme aldose reductase. So accumulation of the galactitol and various other toxic substance mainly occurs in the lens of the eye. So there will be the infantile cataract in the child. So what are the various clinical features? The symptoms appears in the infants in the feeding stage, where they are feeding, where there is rich of galactose substance, like they are feeding breast milk or any other substance that has rich content in galactose. The symptoms appear there specifically. So what are the various symptoms? The various symptoms are failure to thrive, jaundice, hepatomegaly, infantile cataract, that is one of the main features of the classic galactosemia, and intellectual disability. So the children with classic galactosemia can also predispose to E. coli sepsis. So in the neonates who have the classic galactosemia, they can also predispose to the E. coli sepsis. So what is the treatment? So we exclude the galactose and lactose diet. So if we inhibit the galactose and lactose diet, then there will be the less formation of the galactitol. So it will eventually treat or mainly manage the classic galactosemia. So here we discuss the galactose metabolism. The galactose mainly is converted into galactitol, or the galactose may ultimately goes into glycolysis and glycogenesis. And also we talked about the galactokinase deficiency and classic galactosemia. So this concludes our galactose metabolism and its disorders. Thank you.